Ever felt like engineers and welders speak two different languages? It's a common challenge in metal fabrication shops everywhere. Engineers design for strength, performance, and code compliance, while welders bring those designs to life on the shop floor. When these two vital roles aren't perfectly aligned, it can lead to confusion, rework, and costly delays. This video will highlight 7 crucial insights engineers often wish welders understood better about the why behind their designs and procedures. Knowing these can transform your welding operations, boost productivity, and elevate your job performance. Let's dive in. 1. Welding procedures are not optional, they are mandatory. You've seen those welding procedure specifications documents, right? Sometimes they might feel like a list of arbitrary rules, but for engineers, the welding procedure is a meticulously crafted blueprint, often following structural welding codes like AWS D1.1 that dictates exactly how a weld should be made. Why so specific? Every parameter, from amperage and voltage to travel speed and shielding gas, is chosen to ensure the weld meets specific strength requirements, achieves optimal penetration, and avoids defects. Deviating from the qualified welding procedure can jeopardize weld quality, leading to rework, inspections, and even catastrophic failures. Think of the welding procedure as your recipe for success. Stick to it, and you'll consistently produce high-quality welds, saving everyone time and money. 2. Heat input is critical. Engineers often specify a minimum or a maximum heat input in the welding procedure. For welders, this might just seem like another number to hit, but it's far more critical. Heat input directly controls how fast the weld metal and the heat-affected zone cool down. Why is cooling rate so important? It profoundly influences the microstructure of the steel. If certain carbon steels, especially medium to high carbon steels, cool too quickly, you risk forming brittle structures that are susceptible to cracking. However, if certain stainless steels, like austenitic stainless steels, cool quickly, it is a good thing, while cooling too slowly can lead to significant problems such as sensitization. Engineers calculate these limits to ensure the finished weldment has the desired mechanical properties and resistance to weld failure. Understanding heat input helps you control the fundamental changes happening within the metal as you weld. 3. The impact of sequence and number of passes on distortion. Distortion is a fabricator's headache, leading to parts that are out of tolerance and require costly straightening or even scrapping. What many welders might not realize is that the welding sequence, the order in which individual welds or weld passes are made, is often engineered to minimize this problem. As weld metal cools, it shrinks. Without a planned sequence, these shrinkage forces can pull the material out of shape. Engineers carefully consider these forces and design a sequence that balances them, much like playing a strategic game of chess. Following this sequence is key to keeping your assembly straight and avoiding unnecessary rework. It appears counterintuitive, but yet it is another reason why those welding procedures must be strictly followed. 4. Preheat and interpass temperature are critical. Why bother with preheat and interpass temperature? These aren't just suggestions. They're essential crack prevention strategies, especially when welding carbon steel or high-strength materials. Cracking, particularly hydrogen-induced cracking, also known as cold cracking, is a major concern. When you weld, hydrogen can get trapped in the molten metal. If the weld cools too quickly, this hydrogen cannot escape before solidification, leading to cracks that can propagate over time and cause weld failure. Preheating slows down the cooling rate, giving trapped hydrogen time to diffuse out of the weld. Maintaining a minimum interpass temperature ensures that subsequent weld passes don't cool too rapidly. Engineers specify these temperatures based on material thickness, chemistry, and joint restraint to ensure the weld's integrity. Oftentimes, welders don't check the preheat and interpass temperatures adequately, and this can lead to failure. It is imperative that welders strictly adhere to the specified preheat and interpass temperatures. 5. Not all steels are the same. Material grade matters. You might see different steel grades come through the shop, from common A36 to specialized alloys. While they all look like steel, engineers select each material grade for its unique properties and how it will perform in service. Crucially, how to weld carbon steel versus how to weld stainless steel or other alloys can be vastly different. Engineers understand that each material reacts uniquely to the heat of welding. For example, some steels are more prone to hardening or cracking in the heat-affected zone without proper preheat or controlled heat input. Using the wrong welding procedures for a specific material can lead to defects, reduced strength, or premature failure. Don't make the assumption that what works on low-carbon steel is acceptable for welding high-carbon steel simply because the welds look the same. 6. Proper consumable storage is of utmost importance. You might wonder why engineers and quality control personnel are so particular about how filler metals are stored. It boils down to one word: hydrogen. Many welding consumables, especially low-hydrogen electrodes, are designed to minimize hydrogen in the weld metal. However, if these consumables absorb moisture from the air due to improper storage, that moisture introduces hydrogen into your weld pool. As discussed with preheating, hydrogen is a primary culprit for hydrogen-induced cracking, a major cause of weld failure. Proper storage is a simple but vital step in ensuring optimal weld quality. It's a small detail with huge implications for the finished product. 7. Your feedback is invaluable. This might be the most important point of all. Engineers genuinely value the welder's input. While engineers spend their time designing and calculating, the welder is on the front lines, seeing the real-world challenges and nuances of the welding process. Welders notice if a joint is difficult to access, if a material is behaving strangely, or if a particular parameter consistently leads to issues. This hands-on experience provides invaluable feedback that can help engineers refine designs, optimize welding procedures, and ultimately improve the entire fabrication process. Good communication between the shop floor and the engineering office is the fastest way to solve problems, increase efficiency, and boost overall welding economics. Bridging the gap for better welds. Understanding these 7 points can significantly improve the collaboration between engineers and welders in your facility. It's about recognizing that everyone plays a critical role in achieving high weld quality and maximizing productivity. If you liked this video, please give us a like, subscribe to our channel, and share this video. And if you haven't watched our video on 6 things welders wish engineers knew about welding, we recommend that you do. It's crucial to understand both sides.